Hey everyone, it's Perry from Math Together Canada, back again with part 2 of our AMC 10A series featuring Prince Zhang. In this video, Prince takes on questions 11 to 15, a set of problems that introduce trickier logic and deeper thinking. Watch closely as he breaks each one down with clear explanations and thoughtful strategies.
Alright, let's start with problem 11. So it asks, how many ordered pairs of integers m, n satisfy the square root of n squared minus 49 is equal to m? So first off, let's rearrange this equation. And now we can use difference of squares to factor it. Now since m is equal to the square root of a number, we know that m must be non-negative, so we know that m plus m is greater than or equal to n minus m. So now we can do casework on all the factors of 49. And now we can solve for m, n. Now we can plug these back in to make sure they all work, and they do, so our final answer is D. There are 4 ordered pairs. Alright, now, problem 12. Zelda played the Adventures of Math game on August 1st and scored 1700 points. She continued to play daily over the next 5 days. The bar chart below shows the daily change in her score compared to the day before. For example, Zelda's score on August 2nd was 1700 plus 80 equals 1780 points. What was Zelda's average score in points over the 6 days? So this is pretty straightforward. One way we can do this is to just calculate her daily score. So August 1st. Now we can just add these up and then average them. And here we get 1715. So our final answer is E. 1715 was her average score. Now, problem 13. Two transformations are said to commute if applying the first followed by the second gives the same result as applying the second followed by the first. Consider these 4 transformations. First, there's a translation 2 units to the right. There's a 90-degree rotation counterclockwise about the origin. There's a reflection across the x-axis and a dilation centered at the origin with still factor 2. So first let's change these transformations into mathematics. So if we start with a point x comma y, this will go to x plus 2 comma y. And now we'll do the same thing for all of them. So now we can go through each of the 6 pairs. So let's call these A, B, C, and D. Now if we do A then B, we will get that x comma y goes to negative y x plus 2. If we do B then A, then we get negative y plus 2 comma x. So this is not, these two transformations don't commute. Now let's do A and C. And C and A. So this one does commute. A and D. Now D and A. So this one doesn't commute. Now we'll go B and C. Now C and B. So these also don't commute. Now we'll do B and D. D and B. So this one does commute. And finally, C and D. Now this one also commutes. So in total, there are 3 that commute, so our final answer is C. Problem 14. One side of an equilateral triangle of height 24 lies on line L. A circle of radius 12 is tangent to line L and is externally tangent to the triangle. The area of the region exterior to the triangle and the circle and bounded by the triangle, the circle, and line L can be written as a square root of b minus c pi, where a, b, and c are positive integers, and b is not divisible by the square of any prime. Find a plus b plus c. So first off, let's start with a diagram. Diagrams are always really important for geometry questions. My diagram isn't great, but we'll go with it. So since it's tangent, we know that this is a right angle, and this is a right angle. Let's name our points. We'll call this O, A, B, C, D, and E. So here, since it's equilateral, we know that the angle ACB is equal to 60 degrees. So we know that ECD is equal to 120 degrees. Now we also know the other degrees, OEC and ODC, they're both 90 degrees. So we can find the angle EOD, which is equal to 360 minus 90 minus 90 minus 120, which is equal to 60 degrees. Now since ECO and DCO are congruent, this angle is equal to this angle, and they're both half of 60, or equal to 30 degrees. So since we want the area here, we can find that by finding the area of the quadrilateral ECDO subtracted by the sector area of EOD. So since this is 30 degrees, we know that CD is equal to 12 over root 3 or 4 root 3. And so the area of ECDO is just 4 root 3 times 12. Now the sector EOD has an angle of EOD, which is 60 degrees. So we can find its area with 60 over 360 multiplied by the full area of the circle, which is 12 squared times pi. And now we simplify, we get 48 root 3 minus 24 pi. And now we add these up, and so our final answer is D. Now, problem 15. Let m be the greatest integer such that both m plus 1213 and m plus 3773 are perfect squares. What is the unit digit of m? So let's equate these to some variables. So let's set m plus 1213 as equal to p squared, and m plus 3,773 as q squared. So now if we subtract these to get rid of the m, we get q squared minus p squared is 2560. Now we can factor out Now, since they're integers, q minus p and q plus p must have the same parity. And also, since they're both positive, q plus p is greater than q minus p. So to maximize p and q, we want to maximize q plus p and minimize q minus p. So since they both have to be even, we'll set q minus p to be the lowest possible, which is 2. And now this means that q plus p will equal 1280. Now by solving this, we find that p and q are equal to 639 and 641 respectively. And now finally we can solve for m. And so m is equal to 639 squared minus 1213. Since we only want the units digit, we can take a mod 10, which is equal to 9 squared minus 3 mod 10. Which is equal to 8 mod 10. So that's our answer. So our answer is E.
And that's it for part 2. Big thanks once again to Prince for helping us navigate through these more challenging problems. Get ready for part 3, where Prince will dive into questions 16 to 20 and the problems really start to heat up. And if you'd like to join our mission of spreading a love for math, we're always looking for new voices. Contact us at contact@mathtogether.ca to record your own contest or concept video with us.